In order to maintain a CPU's full performance, it is especially important to have a sufficient cooling solution for your CPU. In this video, we'll be going over the physics behind major types of coolers that you can buy on the market. To understand how coolers work, you have to know the first law of thermodynamics, that energy can neither be created nor be destroyed. Therefore, what coolers do is not eliminate heat but transfer heat to another substance away from the CPU, and in this case, it's the air. As you may already know, we normally have two ways to cool a CPU, using either an air cooler or a liquid cooler. Both coolers work by transferring heat from the CPU to an object with a high surface area for thermal dissipation. In an air cooler, the heat dissipator is the heatsink. In a liquid cooler, it's the radiator. Both require fans to speed up heat exchange. Therefore, both an air cooler and a liquid cooler require air to take away the heat, and their difference really lies in the way they manage to transfer heat from the CPU to the heat dissipator. Let's take a closer look at an air cooler. An air cooler usually consists of several heat pipes connecting the base that's in contact with the CPU, and the heat sinks that dissipate heat through the blowing of one or more fans. These components are usually made of copper or aluminum, for their high thermal conductivity. One thing to note is that contrary to what people normally think, heat pipes are actually hollow. Inside a heat pipe is usually liquid water that evaporates at one end and condenses at the other end. The condensed water then travels back to the hotter end to continue the heat transfer. This process of phase change allows heat pipes to have a thermal conductivity of between 1,500 and 50,000, way higher than that of copper and aluminum. A liquid cooler transfers heat quite differently. As its name already suggests, a liquid cooler transfers heat through liquid water, but not by phase change though. As you might already know, water has the highest specific heat capacity among any liquid, making it ideal for heat containment. But its low heat conductivity makes water unable to transfer heat over long distances. Therefore, a liquid cooler is usually equipped with a pump that circulates the water, allowing the hot water to reach the radiator and be cooled. A liquid cooler's installation is more flexible compared to that of an air cooler. But at the same time, the price of a liquid cooler is often higher than that of an air cooler of the same performance. Which cooler to choose really depends on your budget and needs. Lastly, thank you for watching, and see you in the next one.